Today we're going to talk about graphing quadratic inequalities. So we're going to do standard form, vertex form, and intercept form like we always have, except now we're going to talk about inequalities. So I want you to think back to graphing lines for a second, where when you graphed a line, and then you would have to shade, either below that, or sometimes you had a dotted line, and you would shade above the line. So it's the same idea, except now we're going to be graphing parabolas. So you're going to graph the equation, whether it has standard form as shown, or sometimes you'll be given vertex or intercept form. Then you're going to have to remember from Algebra 1 that if it is a greater than or equal to or less than or equal to, that we're talking about a solid line or a solid parabola. And then if it's strictly greater than or strictly less than, we're going to have a dotted line or a dotted parabola. You're going to test a point. So you'll test a point. I always try to test to 0, 0. Sometimes it's not possible. It's not possible if your graph is going through the origin, but we always try because that's a nice easy point to test. Otherwise, pick any point on your parabola, and then you're going to shade where that point is if it's a solution. Otherwise, you're going to shade where that point is not. Now, there's only two different regions of the parabola. And those two regions are either inside the parabola, so inside that U shape, or outside of the parabola, everywhere outside. So when you're doing lines, we're shading above or below. This time we're going to shade either inside or outside of the parabola, depending on where our solution is. Okay, so in example 1, we have y is less than or equal to x squared minus 4x plus 3. So we need to identify the vertex, the axis of symmetry, and we need to make a table of values before we can graph. So everything that we've done with graphing is the same. So we're going to go ahead and treat this problem like everything we already know. First thing we're going to do is find the vertex, which means we're going to have to use our fancy formula, x equals negative b. Well, if we look at our equation here, our a value is 1. Our b value is negative 4, and our c value is 3. So negative b would be positive 4 divided by 2 times my a value of 1. So this is finding the x-coordinate of the vertex. So when we simplify that, that becomes 2. Well, that's what our axis of symmetry is. Remember that your axis of symmetry is a line, so x equals 2. Now we're going to take that x, we're going to plug that back into our equation to figure out what our y-coordinate is. So I'm going to have 2 squared minus 4 times 2 plus 3. So if I go ahead and simplify this, 4 minus 8 plus 3, negative 4 plus 3 is negative 1. That right there, that's the y-coordinate of my vertex. So the vertex is going to be at 2, negative 1. Now I know it doesn't ask for this, but since this is a positive, since that a value is positive, that means it's going to be opening up. And when it opens up, that means we have a minimum, and that minimum value would be at negative 1. So let's go ahead and make our table of values. So remember I told you that you have this special little box, and inside that special box is going to go the vertex. So 2, negative 1. We're going to pick a couple numbers bigger, like 3 and 4, and a couple numbers smaller, like 1 and 0. So when we plug these numbers in, you're either going to use your table function, or you're going to take these x values and you're going to plug them into your equation, consistent with everything we've done so far. So filling in our table, we should get when x is 0, y is 3. When x is 1, y is 0. We've got our vertex. When x is 3, y is 0. And when x is 4, y is 3. Now remember that we've got that symmetry in that y column of the table. That's good. That's because our parabola is going to be symmetric. So now everything that I've done is consistent. I'm going to go ahead and start graphing. So 2, negative 1 to the right 2 and down 1. That's going to be the vertex. And then I'm going to put the axis of symmetry, dotted line through the vertex. And I can graph my other points, 1, 0, and 3, 0. Now look at that. They're both equal distance from the axis of symmetry, which is what it should be. 0, 3, and 4, 3. And each of those points are 2 away from the axis of symmetry. So at this point, before we connect the dots, we have to take into consideration whether it's a greater than or equal to, or less than or equal to sign. So since it's a less than or equal to sign, that means it's a solid line. So when I sketch my parabola, I'm going to sketch a solid line. I missed, sorry. Good enough. All right, so we've drawn our parabola. Now what we're going to do is we have to test a point. So you'll notice below your graph you have this whole test business. I always try to test 0, 0 if I can. Now 0, 0 is definitely testable here because it is not a point on my graph. So that just means you're going to plug in 0 for x and 0 for y. So 0 is less than or equal to 0 squared minus 4 times 0 plus 3. So 0 is less than or equal to positive 3. Is this true or false? That's what you have to ask yourself. Is 0 less than 3? Yes, 0 is less than 3. So that means it's true. So that means that 0, 0 is a solution. Okay, so 0, 0 is a solution. That means we're going to shade where 0, 0 is. Well, if you notice, 0, 0 is outside of my parabola. I had just told you that you're either going to shade inside or outside. So since 0, 0 is outside, I'm going to shade outside of my parabola because we discovered that 0, 0 was a solution. Okay, now we have a parabola that is in intercept form. So if you need to rewrite this as y is less than negative x plus 0 and x minus 4, you can clearly see those intercepts. So we're going to go ahead and identify our p and our q values. So p would be 0 and q would be 4. Remember, your p and q values are opposite of what you're seeing in those parentheses. So when I'm doing this, since it's in intercept form, I don't need a table. Okay, remember for intercept form, you need your x-intercepts, your vertex, and your axis of symmetry. So I'm going to go ahead and add in right here x-intercepts because we are going to find our x-intercepts, which are going to come from the p and q values. So p equals 0 is going to be giving me an x-intercept of 0, 0, and q equals 4 would give me an x-intercept of 4, 0. So I've got my two intercepts. Now I need to find the vertex. So recall from intercept form that x equals p plus q divided by 2. So that's going to simplify to become 2. That is the axis of symmetry. Now we take that, we plug that back into our original equation to get our y. So negative 2 times 2 minus 4 will give us positive 4. That is the y-coordinate of my vertex. So my vertex will be at 2, 4. Now since this parabola is opening down, and I know it's opening down because that a value is negative, I'm going to have a maximum, and that maximum would be at 4. Okay, so I'm going to go ahead and graph these points now. So I have a vertex at 2, 4, which is to the right 2 and up 4, and then I'll put the axis of symmetry through that. I've got an x-intercept at 0, 0 and an x-intercept at 4, 0. Now again, before I sketch my parabola, I want to remember that this equation right here is a less than. So since it's a less than symbol, that's going to be a dotted line. That's why you're going to see that now I'm going to sketch this parabola with a dotted line. Now we have to determine where to shade. Are we going to shade inside or outside of the parabola? So I told you that I like to test the point 0, 0, but if you notice right here, the point 0, 0 is on my parabola. So since it's on my graph, of course it's going to be a solution, but the question is, where am I shading, inside or outside? So I need to pick a point that's distinctly inside or outside of the parabola, and it doesn't matter. I'm going to go ahead and pick this point right here. Okay, that's distinctly not on my parabola. It's distinctly outside. So that ordered pair is 0, 2. So that means I'm going to go ahead and plug in 2 for y because the y-coordinate is 2 and 0 for x. So y is 2 less than negative 0 times 0 minus 4 is 2 less than 0. Okay, again, we're asking ourselves this question. Is this a true or false statement? Is 2 smaller than 0? So since this is a false statement, 2 is not smaller than 0, that means 0, 2 is not a solution. So that's not a solution. Well, that point was outside of my parabola. Remember, we tested outside. Now I told you you're either shading inside or outside. So if the outside is not a solution, then that means inside is a solution. Okay, you could have tested a point inside the graph. Let me show you that for an example. If we tested the point 1, -1, right here, that's inside the parabola. So if I wanted to test 1, -1, that means I'm going to take -1 and plug it in for y, less than -1 times 1 minus 4. So it's -1 less than +3. It's -1 less than +3. You can see that this is a true statement, and this point right here is inside of the parabola. So it depends on which point you pick, and then just deciding if it's true or false where you're going to shade.